Today is 20 June. Today we are going for the problem of the day 1840 maximum building height. So this is very unique problem. So we need to basically thoroughly understand the problem. Then I try to basically get all the details related to solve this problem. So it's not related to any specific you can say topic. It's just some understanding or observation which takes you to which needs you to basically solve this problem. So we'll start with that. So if you read the problem, that's it. I already read it, so I let you know it's a summary that the building start from 1 to n, and the height of each building is not negative in integer, and the height of the first building will be the 0, and every height difference between any two adjustment is cannot be greater than 1. Suppose let's say the first building is 1, then only the second building can be 2, or previous building before that can be 0 or 2. It cannot be like 3 and then here it's 1. So this is the restriction which is talking about here. And then maximum height of a building can be restricted with the restriction array which has the ID and the maximum height, and it also guarantees that there is no other restriction. There is only one, at most one restriction for every ID or building number, and we need to find the maximum height which we can achieve through the building. So this is the problem statement. So to solve this we need to basically three things we need to be understand. First, the height of increasing any building, it depends not only the forward side, it only also required future of the restriction, depends on the future of the restriction. How? Here you can see, here we can increase. Suppose we increase height as soon as we know that the limit is not there, and as the limit increase we stop the increasing. Then again we see the restriction is much more. Then we increase the height, then we stop increasing because the restriction is there, then we increase. But here you can say that the restriction is not there. We can increase the height, but in the future we know that this is going to be restricted, so we can't directly go ahead and increase and then decrement by 2, because there is no it's a violation of the cannot exceed 1. This is the third rule. So from this we get to know that it is not only depend on the forward direction, it also depends on the backward direction as well, restrictions. You got that? So so it cannot be solved only one direction. It can also need to be know about the backward direction as well. So we need two passes. This is also indicated here as well. You can find the height range in the restriction build by doing two passes from the left to right and right to left. Also one more observation is there, that the building height can maximize according to the distance. What this means is basically, suppose we there is no restriction as such. We can say there is no restriction, but we cannot until 6 we cannot increase more than 5, because it depends every time it increment only 1. So the distance between the raised building 6 to minus 1 is a 5. Okay, it cannot go beyond that. It's the maximum which we can achieve. So that is also the observation for us. So okay, this is the one thing. And for building 2, 3, 4, 5, 6, 7, 8, 9, 10, we also need to know that suppose we need to find between 2 and 10, the height between 2 and 10, but it can achieve in between the maximum in between these. Suppose we want to find the maximum height between 2 and 10, then what is the course of action? We can go increment, and then we need to decrement. It should not be like this it directly increase and then decrease then increase. You should go gradually increment and decrement till the restriction is there. So you need to understand that suppose we start from here and the building get increasing increment one by and ascending, basically ascending then descending. So for if you know, for ascending, suppose there is a p. P is the height of the maximum height which can achieve, and then from h1 height, h1 height, suppose it takes 2 to 3, 3 to 4, it increment 1 by 1 to 4 to 3, that's the height, or we can say distance. We need to increment ascending, we need to ascend this, okay, and then we need to descend that same till h2. Suppose somewhere it ends at h2, so we need to ascend p then descend to h2, the p h2. So this is the total length which we can achieve, okay. We can say this is the total distance between 2 to 4. This need to be done here. So if we solve this problem, then we get 2p minus h1 plus h1 plus h2 equal to d, and we try to solve this problem. We get p as what do you want, d plus h1 plus h2. This can be in the distance divided by 2. So for taking the maximum height which we can achieve, maximum height can we achieve, we need to find the distance between any two numbers and h1's restriction. Suppose some restriction is there, maximum restriction is there, h2 restriction is there, and it can divide it. So this is the core of this problem. Then this is the first thing need to be understand. The second thing is restrictions. Currently restriction is provided randomly. We don't know whether it is going from the here to here, but we can't go from this place to directly here. You need to understand. Suppose there's a 5 number is given here, but we cannot build more than 1 because it's a 0, it's next to it 0, and this is a fixed point. It cannot go beyond that. And here also in a 10th, if you want, if it is given infinite, then we can't go infinite. We only need to, we can go only until 9. 10 minus 1 is equal to 1, because if we increase 1 by 1, everything is green, green. Suppose we don't have restriction, then we go into till 9. It cannot go beyond that. So this is the same restricted, the same given here. We can't go from directly 9 or something like that. It goes only 5. There is no restriction is there. So we need to actually find the restriction, actual restriction from left to right and right to left. So there are two passes. So what we'll do is we are going to do is we can go from here. First we need to put we need to find the restriction. So we need one array which has all the restriction. Okay, sorry. And we will add the restriction of there's a 1 which has a 0 as a number. Then we add all the restriction into that. Then we modify this restriction, actual restriction. Currently we are just putting every restriction into the list. So we will go okay, we have an what is that? Okay, we are not going with that. sorry, my bad. Start this. So now we have restriction, and now we are going to add. Okay, so this dot add restrictions. Now we will modify the restrictions. So from left to first we go left to right. So what we are going to do is we check. We are going from left to right. It's very simple. Once again. Also, we need to sort this as well. Correct. Collections dot sort, because currently 5 3 2 4, if something is not so we use collections dot sort, and we use some array function to sort. Okay, now it's getting sorted. It takes 2 elements and then compare the initial, the first values, and then fix the value. Now it is done. So we are going with the also as we know that some building doesn't have the any restriction, and it can be with a distance, so we will go with the so last doesn't have any restriction. Start. Size. And the value of 0 is not equal to n, basically size. If you know that maximum height can be achieved with the n, if the last restriction is not given, we need to provide the last restriction. It can be achieved list dot add, what would be the last restriction? If you know, as I mentioned, we can go increment till maximum height. So last restriction will n -1. Okay, now we are going with the pass. So we have the list, so we will check, we will go with the list dot size. So first we need to check how many distance is covered. Distance is covered. So distance, suppose there are 2 restrictions are there, from here to here. Some restrictions are there. Suppose 2 5, and after 2 we have that 5. The distance will be 2 to 5 is basically 3. So uh, we don't have to go from 0, we need to go from 1, and then list dot get I 0 minus the previous distance minus minus 1. So this will be gives us the distance between two restrictions. Suppose 2 5 is there and 5 3 is there, so it will gives us the 3. And as we know that it can only be updated, the value can be updated because we need the real restriction, how much is there. So I of that 1 can be updated with math dot minimum of the current restriction which is already present there, or the previous one plus distance. Yeah, previous one and plus distance, because yeah, this will be the case. Why this will be the case? Because suppose previous building has the 5 restriction and it go beyond something like that, so some extensively, so it can go 5 till so we in between there is no restrictions, we can go anywhere, but from 5 to 3, 2 has 5 and 5 3, so in between these two we can go only by that. It can go maximum, suppose the restriction is there, this one 5, suppose it's restriction is this one, so it can go between these two, the distance between these two plus the previous one plus the restriction, but it is 0. We have already provided that it is 0, so that's the reason. And then this is the one place, and now we go with the from the backward. Okay, and we can go list dot size minus 2, and it go increment till it hit the 0, I plus 1 distance, and I will be updated as I or plus 1. Yeah, so this will update the whole from forward till backward. It automatically updated it. Now next is, now we need to find the real distance, which already we solved the problem, that height p. So we need to go for every restriction and then find out between these two. Suppose from here to here, what will be the peak we can achieve from here to here. Suppose 2 to 5 and 5 to 2 to 5, how much we can achieve from 2 to 5. This is the last and how much we can achieve here, and from then 5 to 7, how much we can achieve in between these two, because we already know this much is already there and this much is already there, as we mentioned. Then we can only increase. So we start with 1 because 0 will be not considered, and then go till the size, and I plus plus, and we need to find the previous one. Suppose h1 we need to find, and then list dot get I minus 1. We have the restriction as 1. Okay, we also need to find the distance, because distance is also crucial here. So total distance we need to find. Distance is one of the key here. d1 it will be the 0. The same way we need to find the second restrictions value, d2 h2, then int d is equal to we can directly calculate. I will directly calculate. I minus 1. So we need to find the peak, as we already know peak. So it will be d plus h1 plus h2 divided by 2. And if we know about the peak, int peak, then peak can be math.max peak. Oh, sorry, return peak. Yeah, so we got the error. Okay, if, because we are going for the and, not if. What is the problem here? Okay, it should not say. Okay, it takes time. That's a hard problem, so it will take time, approximately. Oh shit. I copied everything. I wasted 5 minutes. Okay. Okay, it should not be. It's int. Restriction. Oh. Okay, no. Sorry. Alright. List. What is the issue? Incomplete int cannot be converted to. Okay. we don't need to do anything here. Yeah, this will suffice. Okay, we are able to. Yeah, thanks. This is the question for today. It's a hard problem. We need to understand each and every bit. We can solve directly here. We don't need this. We don't need this. So yeah, thanks.